Hi and thanks for watching this video on DIETERpy. My name is Alex and on behalf of my colleagues Carlos, Martin, Wolf and Alex, I'm going to present you the key features of our new model. Before diving into the new functionalities, a few words on the model itself. DIETER is an open source dispatch and investment model to analyze the power market. It is a linear cost minimization model that takes all hours of a full year into account and takes a long-run equilibrium perspective. Typically, we use DIETER for mid to long-term scenarios with high shares of variable renewables, and we focus mainly on temporal flexibility and sector coupling options. I'm very excited to present you DIETERpy, which is a new framework that embeds the existing GAMS model core into a new Python environment, adding new features and making the entire model more accessible. But first, I'm going to hand over to Wolf, who's going to present a few key publications done with DIETER.
We published a couple of papers based on DIETER in peer-reviewed journals. So this one introduced the basic model, an application to electricity storage. Here we introduced the prosumage model and applied it to Western Australia. Here we introduced a sector coupling feature, power to heat, and battery electric vehicles. And there is also a stylized reduced model version used for high-level analyses of electricity storage here, and very recently also here.
Thanks, Wolf. And now I'm handing over to our Python expert, Carlos.
In this section, we are going to show the basic feature of DIETERpy, such as creating the project folder, running an optimization, and visualizing the results. As already mentioned, the first step consists of creating the project folder. This folder will contain all the files required to run our case study. As we can see, the configuration files are in CSV format, mostly. In the documentation, you will be able to find the instruction to edit them properly. After that, we can run our optimization by typing in the terminal DIETERpy run. During this process, different files are going to be created that will contain our results. Once the process has finished, we can see the results by opening the web interface. After typing in the terminal DIETERpy web, a web page will open locally in our computer. We can also set the configurations and run the optimization by using the browser, although this is still under development. So we focus now in the visualization of the results by clicking the report and then in load the data. Once the data is loaded, we can select the graph that we want to visualize the result.
Thanks, Carlos, and thank you all for watching this video.
This is DIETERpy.